Okay, I just want everyone to, get refreshed before I start. I'm not a person who crack joke a lot, so I don't know how to make you laugh, make you refresh. What else we could do? Unfortunately, probably nothing. Okay, so we'll get started. So before we get started, I just wanted to know how many of you heard about Druid? Okay, great. Probably that is less than 10%. So maybe I will take, so we had a previous session, we talked about the basics of Druid in a previous platform attorneys meetup. So this was an extension for that first talk. The topic here is optimizing high concurrency real-time analytical query. So I would like to deviate slightly from there, and I will give you a brief introduction what Druid is. So I added some additional slides 5 minutes back, 10 minutes back before the actual event start, so that I can accommodate that. Sorry. So main reason for that is I want to make this your time most useful, productive. That's the main intention for this day. So we'll first dive in deep on, intro on what Druid is, what is capable of. Then after that, we will get into the real-time optimization part. Probably some areas I may have to skip because I included some agenda. Anyway, giving this introduction itself, I lost around 5 minutes. Let's get started. Yeah, my name is Tijo, lead solution architect at Imply. Just skip this slide. I already have some of the answer, but we are in interest of time. I'm skipping this. Yeah, today's agenda. So we'll have introduction of real-time ingestion, and how Druid queries the real-time data, and how to optimize the real-time query. Okay, so these are the main 3 agenda for today. And I believe I have 45 minutes, right? Let's try to wrap it up. Okay, so a brief history of Druid. So it's first created by created for the user-facing analytics. What do you mean by user-facing analytics? Means you have a graph which is showing in your application, right? Graph, when you show a graph, that means it's a group by query, right? And this group by queries are really expensive in nature. So we call it as, this kind of queries are called as analytical queries, okay? So Druid is first built for powering user-facing analytics, okay? So for example, if you are in your dashboard, if your landing page is a UI, which shows a graph, which means each time you navigate from one page to another and come back to this page, there is a query fired which is a heavy, high concurrency query, right? So that's the big problem, right? We need to optimize that. We need to give that experience. How do you want to give that experience? We need to show almost a real-time data. We don't want to store a historical data, aggregated, pre-aggregated and kept and showing there, and which doesn't give you a real-time feel of it, right? So that first impression of an app is that landing page, that analytics. And because of this nature, it's a high volume because it's aggregated over a lot of data and a high velocity, and it's a complex, complexity is more of in some sort of application like IoT, observability, where the volume of data is very high. So it's a complex in nature. Skipping the rest of the points. Why Druid evolved is, first it evolved from a ad analytics space. Means ads will get revenue when you click on it or when you view on it, right? How much revenue it generate? Very minimal, 0.01 cent or something similar to that, right? Which means that revenue is not worth to store that data. If you are storing that data, you are losing that revenue, right? So we need an analytical system which is very competitive and cheap. Query perspective, it should be very cheap in nature. So that's the evolution of Druid happened. So it's coming from ad analytics space. Now, where Druid fits in. So you might be having stream analytics, Flink, Kafka, that's a analytical engine we can consider. It has the capability to aggregate or answer any queries or anything, but that is not a database. So where we need a analytical database where you can store and process answer your queries, right? It may not be practically not possible to store the data in some S3 or in memory, in both the place or even disk, and answer the query based on, answer the queries at very high concurrency basis. So we need a database there. That's the primary requirement where Druid fits in. Yeah, so just giving you some of the high level, this I showed in last session as well. So at Confluent, it's processing if almost 5 million events are generated per second, 350 queries per second, 24 TB of data gets generated per day, right? So any analytical system which is capable of querying so much of data and give you some result is what we are looking for, right? If you are deploying a big analytical tool like I'm not naming any of them, you will be bankrupt within a month, right? Yeah. So same with Atlassian. Just look at the figure in the blue color, right? 25 million users, less than 100 millisecond is the response time. 5x performance improvement once they move from, I'm not naming that other tool, to Druid. Yep, and Thousand Eyes, it's a Cisco, Thousand Eyes, it's acquired by Cisco. Around 180 metrics, 1.5 billion events per day. Once it moved to Druid, 10x reduction in query latency. You know, any of you working with the application development? Application development, microservices, yeah, okay. So you might be knowing how much effort you are putting in to reduce the latency, right? Whatever the request, it has to be for, when I was an engineer, it was around 250 millisecond. Now it is further less, right? Nobody can accept anything greater than 1 second, right? So you need anything, not for the 1 second is not the latency from the database. The latency is to end to end. So it include your microservice latency, it includes the network latency as well. Yeah, assume your server is hosted in Singapore, yeah, 100 millisecond gone, right? So even that is also important for it. Now here if you look at it, the latency is critical. So any user facing analytics, lot of work goes in on the database side, how to tune, improve the query performance better, right? Because all of the sites are, the latency is constant. There is not much latency you can save in the microservice layer, right? Okay, yeah, so I'm just rushing through the 2 million events per second, 2.5 TB raws queried in less than 1 second, 2x reduction once they move to Druid. Okay. Yeah, Amazon Music is also using the Druid. Yeah, okay, these are some of the users. Wait, what happened? Oh, sorry. It was not intentional. Yeah, okay. So just giving you a view on what the architecture looks like. Okay. So basically, we have something called broker. They have something called which is handling the query. The broker accepts the queries from the user, and after that it delivers to the data servers where the data processing happens in the data servers, and that data servers is distributed in multiple servers. Okay, and there is one other component which is in the data servers, which is called the indexer, which handles the real-time data. We will cover more about the real-time later because that is the main focus for today's session. And then the broker receive all the partial result from each and individual servers, which is indexer and historical, and merge the result and send it back to the user. Now, I'm not going in deep on other areas. So this is in general how Druid works. At the same time, you have real-time data which is getting ingested. It's parallelly getting ingested along with the query processing. So we will cover that more in the next slides. Okay. Now, so what Druid solves? So basically, if you think about a Lambda architecture in the sense, how many of you know Lambda architecture? I don't need to. Okay, probably I need to explain. So Lambda means you have real-time data, which is in Kafka, and probably you have historical data, means Kafka, let's say it stores 7 days of data. So what happens to the data maybe after 7 days? You have to move it to some other place. Let's say you move it to S3. Okay, so the data is in S3 and your data is in, real-time data is in Kafka. Now assume you are running a campaign and that campaign is checking for how the campaign is performing in the last 1 week of. That result with a campaign which ran for last 1 month back. Okay, so you need historical data, right? So you need to merge these two results together. Only then you can get to know how your current campaign goes. Everything is relative, right? You run a campaign, you know what is the result. You are running another campaign, you are expecting a result. Why you are expecting the result? Because you ran a campaign 1 month back, right? So that's what you are comparing, right? So you need both. Now, how to solve it? It's using an architecture called a Lambda architecture, where your real-time and batch will be merged together and will be providing it. So we call it as a Lambda architecture. Now, historically, Sparks has the capability of streaming. It has this capability of batching, but you cannot give a single layer and fire a SQL query and get both the result from both the places and merge it together. You have to custom write something, right, to merge that result back. So basically what Druid does it gives a single view on the batch data as well as real-time data. So you don't need to worry about it. Now, for this topic, we are not talking about the batch data. We are talking only about the real-time, how the optimizing the real-time works. Okay, all good? Yeah. Now, let's say this is how a real-time architecture looks like. Let's say you have a topic A, the data coming into topic A, and do some sort of transformation and push that into a topic A dash. There is another topic, you don't need to do any transformation, just coming in. In that case, Druid can directly take the data and it's basically you can use any of the REST API or JDBC connection, fire in SQL, get it from Druid. So this is a typical real-time architecture. Okay. Yeah. So let's say I'm just populating what would that transformation be. Yeah, like this. Now, my major focus is on within that red line, red box. Going in deep in that area, right? Okay, so this is what I want to. Now, how it works? Basically, the producer, the data coming to, if you zoom in, the data coming to multiple topics. Data come to a topic, and within the topic there are multiple partitions. So it goes in like this. So from the producer, the data goes to partition 0, 1, 2, 3, like that. Okay, and what Druid does is, Druid real-time tasks, real-time that component, spin up multiple tasks and assign one or more partition based on the task availability, one or more partition, one or more tasks to, sorry, reset. That real-time component start multiple tasks, and each task is capable of reading data from multiple partition. Okay, it can be one partition, it can be more than one partition. It's up to how you are configuring it. Now, this data is ingested into the memory in Druid, and that memory, the data is in memory, and that data can be queried through the Druid engine. Okay. Now again, so we need to know more what is happening inside, right? So let's go in. So here is how it's done. So we have a consumer thread. Now I will slow down, okay? So now this is the major point. So far I will rushing it. I need to be very mindful of the time, so that's the reason I was doing. So now I will slow down. Okay, so let's first introduce what all things are there. So this is a thread. This represents the thread which actually ingests the data. Now, from the Kafka assigns a partition, and from that partition, let's assume we have Kafka topic with only one partition. Okay, let's come into the multiple partition later. So one partition, let's say, is consuming, there is a thread which reads the data from the partition, and it keeps that into memory, right? And the data is ingested based on time, some partition. I mean, it has to split the data into multiple partition. That primary partition, if you remember, and also attend my previous session, it's partition based on time. That's how Druid store the data internally, based on time. So it's split based on time. Let's say if you say your granularity, segment granularity is at day level, it's split at day level and keep it in memory. So logically there is multiple partition within the memory, and that it stores in memory. Okay, and that is handled by that is called a logical time segment. Now happens what? As the data get into the memory, more memory will get consumed. At some point of time, it will get out of memory, right? You cannot keep everything into memory. So there is a configuration called max rows in memory, or max bytes in memory, or intermediate persist period. Okay, based on this three parameter, it take a call to persist the data into the disk. Okay, where it will store? It will store in a directory, in a local disk, where the configuration is Druid indexer task based directory. In that directory, it will store it. Now what happens? How many of you know what is columnar data? Just taking a detour. Columnar, okay. So what happens is, see, when you keep the data, just go back to the previous slide. When you keep the data in memory, how you are receiving the data? You are receiving the data row wise, right? So you are getting first row, then you are reading the second row, you are reading the third row, right? So you are keeping all the data in a row manner in memory, right? But when you fire a query, how the query looks like? For example, analytical query. Let's say select count star from a table where blah 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 grew by country, right? That's your analytical query. Or select sum of something by group by country, right? So that means you are referring only one column. You don't need to read all the column. Those who know columnar, forget about it. So you are reading only one column. So but you need to, if you are store the data in a row-oriented manner, you have to scan all the rows, right? Only then first column, then second column. You are picking only one column, but you need to scan all the rows. But if you store in a column format, you are reading only one column out of it. Whatever column you want to read, you directly come there and read. Okay. So because of this reason, the data in memory, if you think it's fast, it's not so fast, because you are reading many things in the memory. CPU is busy reading things, whereas it's not processing things. Right, no? Again, go back to your computer architecture. Even if you read things, you need to take the data from RAM to L1, L2 cache, L2, L1 cache, and ultimately register. Only then the reading happens, right? So it's not fast. So how can you make it fast? Make it columnar. Now, when you make it columnar, how to make it columnar in Druid is persist. When you persist, it will transform the data into a row format to a columnar format. Okay? Then after that, anyway, there are different mechanisms to optimize it. So that will kick in and your queries will run fast. Okay, now let's go to the next stage. Now, when it persists into the disk, it persists independently, right? It will convert and persist independently. But at the end of some time, like let's say, based on some criteria, let's say your segment you configure the segment to be, let's say, 5 million, or based on some other criteria which is mentioned, 3 other criteria which is mentioned here, you may have to, the crux is you have to merge this intermediate persist into a bigger block of data, right? Why? Because of columnar. You need to make it much more columnar in nature, right? So you need to merge those things together and make it as a bigger segment, right? So that merging will kick in, and then it will push into deep storage. Deep storage is nothing but the time period, whatever you defined as the real time period, maybe let's say 1 hour or 1 day or whatever it is. Once that is over, it will be pushed into deep storage, and that data will be moved to a historical component, and the queries will be answered from the historical component. Okay, so the role of real time ends there. So far so good? Yeah, please feel free if you have any question. Yeah.
The configurations that you have mentioned here, max rows per segment, max total rows, is it configurable per table or for the entire cluster?
Yeah, it's per table.
Per table.
Yeah.
And the other ones as well, max total bytes in memory?
Yes.
That's per
table.
Per table. Okay.
Yeah.
Okay, thank you.
Any questions? Please feel free. I would like to spend some time here. And yeah, so one other thing is, actually I learned from your questions. So maybe you can help me learning a better way. So far so good, right? Yeah.
So as we know that columnar data, it's really easy and fast to query any kind of insights from the data. But there is also an overhead of storing the columnar data, because for every strip of columnar data you store, you need to establish a relationship between all the records, right? So that maybe if you consider a SQL-based tabular data, right? If you have 2 columns and you store it in
maybe a couple of years back, now I don't know. I did some benchmarking. Comfortably, Druid can handle 25 GB of data per hour by one task, which means effectively one thread. Okay, so if you want to do your workload, if you want to analyze your workload and see how many cores are required, then you can pretty much calculate the cost based on that. That is for ingesting the data. Okay. Now again, this data need to be queried. Okay, so I will cover how we can optimize the query side in the subsequent part. Now, this is scalable. Instead of 1, you can have n number of tasks, and that way it is scalable. So, assume if your queries are pretty high, you add more tasks, that's it. Okay, it will automatically balance it across the partition and then ingest it. Okay.
I'll start. You can add more tasks. So, what is the limit on the number of tasks? As in, does it depend on the number of Kafka partitions we have?
Exactly. Yes, exactly. So that's the limitation for all Kafka, not limitation, that's how Kafka works. One consumer can connect at minimum of 1 partition. It cannot take 0.5, right?
Okay.
Right, so yeah, whatever be the number of partitions, that many tasks you can have. So it's always a good practice to have a higher number of partition in Kafka topic, considering the future scalability.
Okay, so in case, so let's say I have 10 partitions, so the max I can consume is 250 GB of data per hour, if I have Druid as a sink.
Yeah,
so
25 GB, yeah, 10 partition, 250 GB per hour.
So if I have more data, I'll probably increase the number of Kafka partitions.
Then increase the number of tasks.
Okay, got it, thanks.
Yeah. Okay, now next part is how the query flow works. Okay, so we talk about the ingestion. Now, so far this areas, we discussed this area, the merging and everything will happen. Now, how Druid works is, there is something called processing num threads. These are the number of threads allocated for querying the data from Druid, from the real time. So we have one thread for ingesting, and you can configure n number of threads based on your concurrency. You can configure n number of threads to query the data. Okay, that's it. Once you set this, and you need to make sure that ultimately what happens is one thread corresponds to one CPU. I mean, if you are heavily processing the data, one thread corresponds to one CPU. So you can, accordingly, you can go with that. But no matter, since it is an IO operation, right? No matter, since it is an IO operation is pretty slow when compared to CPU operation, right? So you can oversubscribe. As an industry practice, you can comfortably oversubscribe to a factor of 2. It's fine. Okay, maybe not more, go more than that. Okay, in case if a high concurrency manner. Yeah, I will talk about it later in the section. You can hold on for that. Okay, otherwise you will end up in thrashing. Yeah, so okay, so how the query flow works. So when you fire a query, actually this processing num threads actually read from all the segments, persisted segment, intermediately persisted segment, in-memory segment, logical segments, and consume that, produce the result, scan the data and produce the result and push it into a processing buffer. Processing buffer is, the reason is keeping in, because it's written in Java, and keeping everything in heap, it actually costs a lot of GC, so we'll push it to buffer of heap, and the intermediate result will be pushed there. Right? And then at the end of the query, once all the data is there, it will be merged together and give the entire final result. Okay, so that's all the query processing, pretty straightforward. Okay. Yeah, maybe at the end of, so in Druid you need to define what is the task duration. Task duration is nothing but you are claiming what is your real timeness look like, let's say 1 hour or something. But so when a task comes up, it processes the data for an hour, and then after that, that task hand it over to another task, and that task goes down. Okay. So you can define, you need to define that. So once that part is done, it will push this data generated, the segment created to a deep storage. Yep, just jumping into the high concurrency part. Okay, so how can you increase the threads? Right. So as I mentioned earlier, processing num thread is one factor you can think about increasing it. So once even though we increase the processing thread, even if we reach the limit of one particular CPU, one particular node can handle the number of concurrency, what else you can do? Let's say you have a 4-core machine, and that 4-core machine you allocate maximum number of threads you can allocate, let's say it's 4, but your concurrency is beyond that. What else you could do? Right? You can enable replica, so increase the replica, which means that it's not one task which ingests the data, there will be multiple tasks which will be ingesting the same data. Okay, so that way also it is scalable. You can, within it, say basically num threads is nothing but a vertical scaling, replica is like a horizontal scaling. Okay, so you want to achieve 10,000 QPS? Yes, possible. You want to reach 20,000 QPS? Yes, no, not a problem. You can reach to any level. Got it, right? Yeah, that's one. Yeah, one other thing. Avoiding CPU thrashing. So in practice, how do you do that? So normally what I've seen is sometimes people starts with a bigger value and try to come down. Don't do that. Start with a smaller value and try to go up. The reason is, if you use a higher value in the beginning, what happens is you will see a less CPU utilization, and that less CPU utilization might be because of a CPU thrashing. Okay, how many of you know what is CPU thrashing? Oh, okay. Okay, just giving you some advantage. Again, going back to old school, how CPU process the data. So basically, bring it from RAM to L2 cache, to L1 cache, and then to register, right? And when you do a multi-threading model, or what happens is this entire stack of loading the variables, local variable, all those things, entire stack will be kept in memory, and another stack might be some other process, another thread, some other thread will be brought into the CPU, and that will execute for some few microseconds or milliseconds, right? That's how the multi-threading happens. Now assume if you give a lot of threads, the time it takes to execute the actual job will be less when compared to the movement of threads, movement of the stack. Loading the stack, unloading the stack, that itself will take long time, more time than the execution itself. Okay, so you will not see, because CPU is not utilizing, because it's all it does is the data transfer, moving up and down, coming. That's then it's actually defeat the purpose of the CPU utilization, you will see lower CPU utilization. You think that, oh, CPU is not utilized, let me bump it again, right? So that's one other problem. So instead of doing that, start with small and then start slowly increase. It's applicable for not only in Druid, any application, it can happen. Yeah. One other way is, what I mentioned is, see, when in memory, it's in raw format. So if it is in raw format, your analytical queries will suffer because it has to scan a lot of data. Instead of doing that, the best way, convert to columnar. What is the best way to convert to columnar? Persist. Make sure that data persists. Use the intermediate persist period. What is the best value for persist? So when a persist happen, it caused some hard disk activity, right? That is itself is slow. Assume you keep very less intermediate persist. What happens is it always try to persist, and that will again cause some issue in the CPU. So what happens is it's very important to select a proper best intermediate persist. So next question is, what is the starting point? Where can I start? Start with 1 minute. One persist to disk in a minute is not huge, right? Your disk perform around 6 GB persist. 6 Gbps is the actual persist speed for a disk. But that is only theory. I never seen any 6 GB persist happen with any of the hard disk. But with the ideal situation, just like our automotive mileage test happened, right? The wheel also curve, the road also rotate. So such kind of situation, it might happen 6 GB per second. But one good point is, good starting point is start with a 1 minute and reduce it further. Okay. Now another is merge buffer contention. I will not go in this slightly high level, so maybe we can skip this. Once you get into the Druid stuff, it will make sense. But always look for a merge buffer pending request. How many merge buffer requests are there? So based on that, you can tweak this parameter. Probably this should have been a slide I should put at the first. So the thing is, leveraging the data model give you much benefit than anything else, any other configuration changes. So in case of a ingestion, the real-time ingestion support only dynamic partition. Those who are aware about Druid understand the dynamic partition. But where the performance will be better for a range partition. So one of the way to improve the performance is to simulate a range partition. How to do it? Use a key while producing the data, which need to be read from the Kafka topic. So what happens is, all the similar data will sit together in one partition, and that goes into one task, which kind of can aggregate it at the time of ingestion itself pretty fast. So most of the work is done at the ingestion time itself. That boosts the performance. Okay, so this is a recent feature which comes up, which is called a concurrent compaction. So instead of doing the tweaking at the producer side, sometimes you might be a platform guy doesn't have much access to the Kafka platform. In that case, probably that may not be the previous approach may not be a good solution. So this you can think of as a concurrent append and replace. So basically, whatever you do in the previous slide, it will be done by the concurrent compaction itself. So that actually improves the performance. Concurrent compaction has a cost. There is a separate task will spin up to do the concurrent compaction. But yeah, in case, as I mentioned earlier, right, if your query concurrency is pretty high, it makes sense to add one more task for a bookkeeping purpose. Okay. Yeah, the last one. You can also do the caching. Peon has the capability to cache the data. This part is little bit tricky because whenever a new data comes in, that cache will get invalidated because cache is no longer a cache, right? So in case of a high concurrency, high ingestion rate queries, really doesn't make any sense to have cache, but need to be mindful about it. But assume you have some data coming in and within memory, you need to keep it in memory for, let's say, 5 minutes, or not even 5 minutes, even a couple of seconds is also fine for a caching. Let's say your ingestion rate is pretty small. It makes sense to use query caching. Segment caching. Yeah, so that's all. Just wanted to give an overview who all are using Druid for in the real-time scenario. Yeah, these are some of the customer. Yeah, so we have a offering, SaaS offering. So you don't need to deploy anything. You can just sign up, create your own account, try it out, which is called Imply Polaris. It's a SaaS offering. There is a free online course available. It's called Learn Druid. You can go to learn.imply.io, and it will create a sandbox for you, and you can try it out. There is a guided tutorial also available, so you just need to follow it, get an introduction to that. Yeah, so far I believe we covered some in-depth understanding of ingestion flow, some deep understanding on real-time query flow, and some factors contributing to real-time query performance. Yeah. Any questions? Yeah.
Redshift is like more like offline analytics, and this is more of real-time analytics, or how we can compare?
Yeah, Redshift is a data warehouse. So data warehouse has the disadvantage that if you increase the concurrency, it will burn your pocket, right? But it's good for a data warehouse kind of scenario where you have heavy joins and stuff like that. It's a good fit.
Okay.
Druid is more of a real time and
this is more for an end customer, and that is more for backend.
Correct, exactly. For a not a BI, low concurrency BI application, I would say. Yeah.
Okay, thank you.
Yeah.
Time analytics.
Yep.
So like on which scenarios, which will be useful?
Pinot and Druid is almost on the same boat. The only advantage we have is we started 5 years back. 5 years early than Pinot. So from the maturity curve basis, it's better for Druid. But other than that, the architecture, everything is almost same. What else the difference is? There are here and there some small differences there, but capability wise, it's the same. Any other questions? Yeah.
One more question. So you mentioned. Okay. So you were mentioning that at every stage, there will be temporary storage, memory storage, and then disk storage. So how do you manage data at every space? Like if at any cases data loss is happening, how do you manage that? Yeah. So at any stage, data loss is happening. How do you manage it? Like you are storing in memory, then in persistent, and then disk. So how do you manage it?
Okay. So real time, the data will be in memory and it will intermediately persist. And that end of the task duration, it will create the segment and push it to deep storage. So that is the inherent process within Druid itself. But after that, you can also define multiple tiers of storage. For example, most likely last few days of data will be queried heavily. So you can define retention rules. You can say, you can also define tiers within Druid, and then you can say after a X number of days, move this data to another tier, like that. So you can define the retention there. So based on that, the data movement happen.
1 or 2 months.
Right.
So I'm doing real-time ingestion from Kafka, and I'm ingesting based on timestamp in Druid. So I have a hourly segment on timestamp. Now, how do we deal with late messages? So if you have late messages, let's say 4 hours late or 5 hours late.
Yep.
So then does those late messages go into the current segment being ingested, or they go into their own relevant segments? How does that happen?
See, okay, so before answering this, I'll just make a statement, is any columnar database is immutable. Okay, so it will not go to the same segment. It will create a new segment and goes to the same time chunk. Okay, so time chunk in the sense, assume you are receiving yesterday's data today. Okay, so it will create a segment for yesterday and it will push to yesterday. So yesterday also there are some data. So there will be one more additional segment with the new data which is coming. Okay, now having lot of segments is not good, because if assume the segments are 2 KB, 4 KB, 5 KB in that range, then it's not a good segment strategy. So what we do is there is option in Druid called compaction. So you can enable auto compaction and say that, okay, anything more than, whatever your real timeness of data looks like, anything more than that, you can configure that auto compaction, and auto compaction will compact the data and make it as a proper segment. Now, since you asked this, there is an anti-pattern. What if you are getting a lot of late arrival data? Let's say you are getting last 1 year of data, 1 year old data. In that case, what you will do? Actually, whenever, in the image which we shown there, right, in the I could not find it. Okay, so what happens is it creates lot of logical segments in the memory, right? When a late arrival happens, it creates lot of logical segments in the memory, and that can cause out of memory, right? Because lot of late arrival means lot of metadata, and all this metadata need to be kept it in memory. So instead of doing that, when you have a late arrival scenario, one best way to solve it is apply a key while producing, apply a key based on timestamp. Okay, so that will go to one particular partition. All late data will go to one particular partition, and Druid will ingest this. No, not a problem. If any more questions, yeah. you can, I'll be here. I'll just want to introduce Kashif also. Yeah, so he is from the Druid team. He's a committer on Druid, so you can stick around. Any doubt, any questions you have, you can please get back to us. Okay, thank you all.
Thank you so much, Tijo.